Good morning and Sairam to all. Structure of atom. This video is last for this chapter. In last video we have done valency of electrons and types of valency, electrovalency and covalency. What do you mean by electrovalency? Electrovalency means if an element either gain electron or a lose electron. In this is a type of electrovalency, and instead of gaining or losing, if you will share an electron, instead of gaining or losing you will share an electron, in that case this is the covalency. Is this clear? So in this video we are going to cover the remaining topic, that is isotopes, radioactive isotopes and isobars. After this chapter will finished. So let us start with the isotopes. What do you mean by isotopes? See, in nature most of the elements have numbers of atoms which have the same atomic number, but different mass number. Same atomic number but different mass number. So with the help of this information you can write the definition of isotopes. What do you mean by isotopes? Isotopes are atoms of the same element. Isotopes are the atoms of the same elements having the same atomic number, but if we are talking about the mass number, they are having different. Clear? So isotopes are the atoms of the same elements having the same atomic number but different mass number. Clear? The isotope of an element differ in the number of neutrons. Why? Because basically, what do you mean by atomic number? Atomic number is number of protons, and if the atomic number is same, that means if atomic number is same, that means number of proton also will be same. Clear? And what do you mean by mass number? Mass number is basically number of protons plus number of neutrons. See, we have already said that atomic number will be same. If atomic number will be same, that means number of proton will be same. So only number of neutrons will be different. Is this clear? Example: 37 chlorine, 35 chlorine, 12 carbon, 13 carbon, 14 carbon. In all the cases, number of protons are same but number of neutrons are different. So basically those elements in which number of neutrons are different is known as isotopes. Clear? See, isotopes of an atom have a same element which have different mass number but same atomic number. Their chemical properties are similar but physical properties may be different. Example of hydrogen is protonium, deuterium and tritium. Clear? Now, all the isotope of an elements have identical chemical properties. I told you that chemical properties will be same, but what are the different? Chemical properties same, but physical property of the isotope and elements are different. Physical property will different. Now, radioactive isotope. Radioactive. See, the isotopes which are unstable. The isotope which are unstable due to presence of extra neutrons. In their nuclei and emit various type of radiations are called radioactive isotopes. What do you mean by radioactive isotopes? The isotope which are unstable due to the presence of extra neutrons in their nuclei and emit various types of radiation are called radioactive isotope. Examples are carbon 14, sodium 24, arsenic 74, iodine 131. They have high energy radiation, and that's why they are radioactive isotope. That's why they are radioactive isotopes, and these radioactive isotopes are harmful for the human beings. Harmful for the human beings. Is this clear? I am reading the slides once more. Listen carefully. The isotopes which are unstable due to the presence of extra neutrons in their nuclei and emit various types of radiation are called radioactive isotope. Examples are carbon 14, sodium 24, arsenic 74, iodine 131, and these all radioactive isotopes are harmful for human beings. Clear? Now, there are some uses of application of radioactive isotopes. What are they? Number 1, radioactive isotopes are used as a fuel in nuclear reactor of a nuclear power plant for generating electricity. Clear? Uranium-235, which radioactive isotope is used as a generating uranium-235. Clear? For what? For generating electricity. Clear? Now, radioactive isotopes are also used in the treatment of cancer. Radioactive isotopes are also used in the treatment of cancer. Clear? Now, radioactive isotopes are used in tracer in medicine to detect the presence of tumor and blood clots etc. in the human body. It is also used as a tracer in medicine. Clear? To detect the presence of tumor and blood clots etc. in the human body. The fourth one is radioactive isotopes are used in industry to detect the leakage in underground oil pipelines, gas pipelines and water pipes. And the last one is radioactive isotopes are used to determine the activity of thyroid gland, which helps in the treatment of a disease like goiter. So these are the application of radioactive isotopes. Clear? Radioactive isotopes are used as a fuel in a nuclear reactor of nuclear power plant for generating electricity. Uranium-235 isotope is used as a fuel in the reactor of nuclear plant for generating electricity. Radioactive isotopes are used in the treatment of cancer. Radioactive isotopes are used as a tracer in medicine to detect the presence of tumor and blood clots etc. in the human body. Radioactive isotopes are used in industry to detect the leakage in underground oil pipelines, gas pipelines and water pipes. Radioactive isotopes are used to determine the activity of thyroid gland, which helps in the treatment of disease like goiter. Clear? So now example. Composition of nuclei of two atomic species X and Y is given there. Here proton is 6, neutron is Y. In both cases protons are 6, 6. Neutrons and 6 and 8. So question is give the mass number. Mass number of both is 6 plus 6. First का आपका 12 हो जाएगा mass number. Because mass number is equal to number of protons plus number of neutrons. Number of proton is 6 over here. So 6 plus 6 is 12. So for the X species, mass number is 12. And for the Y species, mass number is 6 plus 8 is 14. Is this clear? Now, which element and they are represented of isotope. Why they are isotope? Because atomic number is same but mass number is different. That's why they are isotope. Is this clear? Now, bromine occurs in the nature mainly in the form of two isotopes. This 79 30 Br35, 81 Br35. If the abundance of 79, so calculate the average atomic mass of bromine. See, average atomic mass, how you will calculate? Percentage is given to you. Just multiply with the mass number and just add it. Clear? Here 79 is given to you. So 79 into 49. 79 into 49.7 upon 100 plus 81 into 50.3 upon 100. So when you will solve it, you will get the mass number. Clear? Now, isobars. Atoms of different elements with different atomic number but the same mass number is known as your isobars. See, in the case of isotopes, atomic number will be same and mass number will be different. But in the case of isobar, atomic number will be different but mass number will be same. Examples are calcium and argon. Example are calcium and argon. Clear? Atomic number is 14 and 18 but the mass number is same, that is 14. That means number of protons are different but the number of neutrons are same. Clear? Which two of the following atomic species are isotope of each other and two are isobar? See, 230, 230. These are isotopes, sorry, isobars, because mass number is same but atomic number is different. And these are isotopes, Z and Z. This 231 and 233 is isobars, topes, because mass number is different. Clear? Now, write the electronic configuration of any one pair isotopes and isobars. Chlorine का आप लिख दीजिए 287. Argon and calcium for isobars. Clear? Because I told you that. Now, conclusion of this chapter. Atoms are the building block of a matter. Clear? Thomson's atom model is that atom is a positively charged sphere and the electrons are embedded in it. And atoms are neutral. Rutherford did the famous gold foil experiment and said that there is a positively charged center in an atom called nucleus, and the electrons revolve around the nucleus in circular paths. Bohr was the next person. He proposed that only spatial discrete orbits are allowed inside an atom, and while revolving electron does not radiate energy. The subparticles in a nucleus is electron, proton and neutron. Valency is the combining capacity of atoms. Atomic number is the number of proton. Mass number is the sum of number of neutrons and protons in an atom. Isotopes are atoms of the same element which have different mass number and same atomic number. Isobars are atom which has same mass number but different atomic number. Everything is clear to you? So with this, the syllabus of chemistry is finished. If you are having any doubt, you can ask me, and if you want like session, so you can message me in a science or English group. I will take a live session for your doubt and query. Thank you.